My name is Nakazi Solome, presenting to you our AI project that we are working with Kemigabo Claire, which is titled Timetable Generator with AI. This is what we are going to cover in this presentation. About the introduction, the manual scheduling of academic timetables is one of the most hectic, cumbersome, and time-consuming tasks to do in an institution. Apart from time, it also takes some other factors like the number of courses to be taught that semester and their workload, the lecture rooms available, the number of lecturers available, and many more. One of the hardest points to consider is that one lecturer can't teach more than one course in the same period of time for different classes. Students can have more than 2 lectures in the same time frame. A lecture room can't be shared by different classes at the same time, and more of those challenges. These manual methods don't always promise the optimum schedule plan and leads to countless conflicts. Recently, there are many state-of-the-art systems proposed for the task scheduling using artificial intelligence. The automatic timetable generator will use the heuristics to solve both students' needs and administrative needs as well in order to increase flexibility and generate a suitable, accurate timetable with high performance and preferences. A novel genetic algorithm is one of the approaches used for solving university course timetabling problem and iterated local search algorithm. In this work, we focus on the timetable improvement for the students and assesses our results using real data from Brazilian University. About the background and motivation, timetable scheduling has mainly 2 constraints, that is hard and soft constraints, due to the fact that it has a variety of alternatives to select from. The hard constraints are constraints that should be met for proper functioning of the timetable. For example, assigning same lecturer to different course units to teach in the same time. The soft constraints are constraints that should always be met as they carry a penalty if not met. For example, a student having 1 lecture a day, if all met, the automatic timetable generator will generate a better solution. Timetabling is more feasible if it can meet the hard ones and then made to meet the soft constraints. The constraints include lecture rooms, lecturers, students' needs, but our main goal is to produce a suitable timetable which is optimal in terms of cost, time, and putting all the necessary requirements into consideration. In order to obtain the solution, we shall consider the above-mentioned algorithm, that is, genetic algorithm and iterated local search algorithm. The timetable generator will concentrate more on the iterated local search algorithm as it will do the computation search problem and generate a heuristic to solve the difficult problem. About the literature review. In this study, our main aim is to create application that can automate faculty of computing timetable scheduling system. Currently, timetable scheduling done manually is less efficient and consume a lot of time, and also it's less flexible because timetables cannot change easily. It takes a lot of time to recreate timetable without any clashes because there are a lot of things to consider. Most of research is based on few technologies and algorithms. Among those algorithms, local search procedures are more often used in researches and projects. Before come to conclusion, we should discuss about the technologies and algorithms first. Local search procedures. This is one of the common technologies which is used to create scheduling problems. Taboo search, simulated annealing, genetic algorithm, and local search procedures. Genetic algorithm is most commonly used algorithm. Let us discuss the above methods. Simulated annealing. This method is based on probabilistic method that is applied like the global optimum of given function. When it comes to huge search space, simulated annealing gives accurate global optimization. This method is good for use when it comes to search space in different. When it comes to search space, it's different. If our problem contains conditions that we want to reduce or maximize parameters or other things, that problem can be solved by simulated annealing in most cases. Taboo search algorithm can handle huge relations of derivative approach. that can handle and create memory structure in meta-heuristics to solve optimization problem. This approach is used mostly. Fred Clover's ideas are based for taboo search. This system is used to find solution using meta-heuristics approach, which search and explore the solution which are in beyond the local optimality. Genetic algorithm. This algorithm is invented by John Holland. He wrote a book about genetic algorithm called Adaptation to Nature and Artificial System. Genetic algorithm is a heuristic search which have natural evolution features like mutation, inheritance, crossover, and selection to generate solutions to optimize and get good solutions for a problem. Genetic algorithm is used commonly to develop scheduling systems. When scheduling a timetable, there may be a set of solutions that doesn't violate constraints. So when using a genetic algorithm, we get pool of good solutions. So using this algorithm, we cannot obtain best answer because of the evolutionary features like mutation and crossover. This algorithm is more efficient and take less time to search. Supervised learning. Supervised learning uses patterns identified in a training data set to map variables or features to labels. When the labels are categorical variables, the supervised learning task is said to be classification, while the task is said to be regression if the labels are continuous variables. The individuals created over the course of evolution with the genetic algorithm can form the data set for machine learning evaluation. Patrick Kenkayero say that gene values are the variables the supervised learning algorithm can use to map individuals to its fitness, a regression task. Determining if an individual is a feasible solution or an unfeasible solution is a classification task. Incremental learning is a method that updates a supervised learning prediction model with new training examples without losing information learned from past training. About the unsupervised learning technique uses machine learning algorithm to analyze and cluster unlabeled datasets. This algorithm discovers hidden patterns or data groupings without the need for human intervention. Three clustering algorithms based on unsupervised learning facilitate users' scheduling decision while maximizing the system performance in terms of throughput. Two clustering and traversing agents are used when the former is to cluster common lecturers among departments, and the latter is to find unused resources among departments. Ahmed Babey used clustering of common lecturers among departments performed in the clustering agent by two algorithms of K-means, C-means clustering, and the proposed funnel shape clustering, where the clustering process is described through four features of each common lecturer as desirable daily time slots, undesirable daily time slot, desirable weekly time slots, and undesirable weekly time slots. Research gaps in the literature, determining the right data sets, selecting the right data sets and trusted source of relevant data that is accessible, well-governed, and secure as the data sets for timetabling, scheduling using the mentioned method, where few and some had incomplete information and missing information as well. Explainability, the unknown nature of how deep the system will learn models and a set of inputs to predict the output and formulate the timetable, most especially when we split the data for training and testing, was also a challenge. Solutions to mentioned AI technical challenges, getting in touch with AI experts and collaborating with owners of different data sources to provide the datasets, ensuring the best data management environment for sensitive data and training algorithms for AI applications used, providing the policies that inspect the impact of artificial intelligence on decision-making, and frequent audits of the system to solve the challenge of explainability. Dataset description. This dataset was obtained by taking advantage from the Brazilian law that grants access to government information. Due to the fact that University of Brasilia is owned by the government, I was able to require analyzed anonymized information about students' timetable from both semesters of the 2019 academic year. Methodology. The datasets for this project are large and small datasets. However, the university is partitioned into different colleges for easy administration, and this about that the network here is not stable. So I was talking about the methodology. The datasets for this project are large and small datasets. However, the university is partitioned in two different colleges for easy administration, and this document will take advantage of that and further partition it more to different programs or courses so that we can concentrate more on small data since it's easy to deal with. The different methods will be used, that is to say, prior optimization phase and optimization phase. The prior optimization phase, in this phase, we use informed search techniques such as greedy search to obtain the initial solution in the first slot. During the formation of this solution, we first ignore the soft constraints and focus more on the hard constraints. Then after we test if all the constraints are met, the initial solution will be considered. Optimization phase. When the initial solution is gone, the solution is optimized. The iterated local search algorithm together with the hyper-heuristic framework perform the low-level heuristic, and the move acceptance is done to add the soft constraints. Data preparation and exploratory data analysis. Data preparation is the process of preparing raw data so that it is suitable for further processing and analysis. It includes components such as data preprocessing, refiling, cleaning, validation, and transformation. Data preprocessing, which includes preparing and transforming data using machine learning methods. Data preprocessing, which includes preparing and transforming data using machine learning methods. The data preprocessing aims to reduce the size of the dataset, finding relations between and among the features in the dataset, normalize their values, remove outliers, and extract features for further data processing and analysis. It includes several techniques like data cleaning, integration, data transformation, and data reduction. To make the dataset more productive, preprocessing was done using Anaconda, Python, NumPy, and Pandas library. About the missing values, the dataset was analyzed using the function isNull of the library Pandas of Python and a box plot. It was known that the dataset had some missing values and many with zero values, which we removed, for example, the missing information, the missing info. Sorry. These are the results that we obtain. On the left, this shows the data whereby it had missing info, whereby we had not yet cleaned it. And on the right, the data we had cleaned it. We made a correlation matrix and we have a box plot. About accountability. Accountability refers to the expectation that organizations or individuals will put into consideration to ensure the proper functioning of their system throughout its life cycle of the AI systems that they design, develop, operate, or deploy in accordance with their roles and applicable regulatory framework. The timetable generator will also consider accountability in an easy way that its designer will put restrictions to user interfaces, and the admin will be the only person allowed to make changes to its interfaces, like allocating new lectures and the lecture rooms to the timetable to avoid any inconveniences, and the timetable system will automatically update itself to meet the constraints with the help of artificial intelligence, while other parties can only give their views, that is to say the students and the staff, thereby making the admin responsible or accountable for any outcome of the timetable. Conclusion: information technology has evolved in recent decades. The schedule software application has been adapted and enabled to generate and optimize more appropriate timetables in an automated environment for higher education institutions. Literature research reveals that applications from reputable vendors were gradually adjusting the use of spreadsheets, a database management system, schedule editors, web-based tools, and an improved graphical user interface. Timed software applications thus use modern techniques and are therefore able to use them. The other components include the working mechanism, the solution method, and the algorithm used to create a work plan. The timing problem is very challenging, and many possible combinations need to be explored to find a list of acceptable solutions. Since it's impractical to list all combinations, one will choose an approach that calculates a subset or part of it. Such algorithm can give an approximation that is considered an acceptable solution. Heuristic algorithms therefore seem to surpass traditional methods, and using algorithms are even combined to reinforce one another. The latest developments can be found in the field of hyperheuristics. Such solution strategies aim to generate timetables by choosing the right algorithm. However, commercial timetables products do not seem to focus on the actual implementation of such solutions methods in the table application. That's my presentation. Thank you for listening to me.